Good evening, students. So let us look at the next problem. There is a solid sphere of mass m and radius r that rolls down in an inclined plane. What is the angular velocity of the sphere when it reaches the bottom of the plane? Angular velocity you have to calculate. The velocity when it comes to the ground is given by the formula root of 2gh. Since it is a rolling, for that rolling you have to divide by 1 plus k squared by r squared. So v will be equal to root of 2 into g value is 10 into height is h. Answer is there with the g itself. So don't replace g as 10. You keep that as it is. 1 plus. For solid sphere, k squared by r squared value is 2 by 5. For solid sphere, what is the value of k squared by r squared? It is 2 by 5. So what happens to velocity? Root of 2gh by 1 plus 2 by 5 is what? 7 by 5. So 5 goes up. So it will be 10 times of gh divided by 7. So this is linear velocity. But they are expecting you to find the angular velocity, isn't it? You know that v is equal to r into omega. Omega is equal to v divided by r. So omega is v by r. V is nothing but root of 10gh by 7. Whole thing divided by r is there. So omega should be equal to 1 by r into root of 10gh divided by 7. So which is the right option? You can see that option is there in the third option. So third option is the right answer. Come to the next concept. The mole of the oxygen is mixed with 8 mole of helium. What is the effective specific heat mixture of the constant volume? Since oxygen is a diatomic and helium is a monatomic, they have given the moles. One is 8 moles, the another one is 2 moles. Specific mixture is at constant volume. It is at constant volume. Then what is the formula? You know that the effective specific heat of the constant mixture is, you can use the formula N1 times of the specific heat volume at first case plus second molecule into CV of the second case divided by the number of moles, that is N1 plus N2, which is equal to N1 is 2 moles and specific heat of constant volume, this is for oxygen, and N2 is 8, and this is the specific heat constant volume for helium divided by 2 plus 8. Now you know the value for CV constant volume, that is F by 2 into R, where F represents what? Degrees of freedom. F represents what? The degrees of freedom. Now, if you want to find what is the specific heat for oxygen, you know that for oxygen, the degrees of freedom is 5 by 2 R. What is the specific heat at constant helium? For helium is a monatomic. For monatomic, degrees of freedom is 3. For diatomic, degrees of freedom is 5. For monatomic, the degrees of freedom will be 3. So you can substitute that C into what is for oxygen? It is 5 by 2 R plus 8 into, for helium it is 3 by 2 R divided by 2 plus 8 will be 10. So it is 5 R plus 4 3s are 12 R divided by 10 which is equal to 17R by 10. What is 17R by 10? It is 1.7 R. So option 3 is the right answer. Here actually the problem is tough, students. You have to remember what is the value of CV, because without remembering the value of CV, you can't calculate anything. So general formula for CV is F by 2 into R. F by 2 into R. Yeah. Look at the next problem. They have given the arrangement of spring for the block system. What is the ratio of the time period, that is T1 by T2? T1 by T2 time periods. Now, for the spring, please remember the time period is given by the formula for the spring, 2 pi into root of m divided by k. Now we have to solve it for the two cases here. One is for T1, the another one is for T2. Let it be this is for T1. Let it be for T2. This is 2 pi into root of m divided by. What is the spring constant here? Now the spring constant is connected in 3, which is connected with the same combination. So this should be in parallel. So the spring constants are in parallel. So k dash value will become 3 times of k. But length also becomes L by 3. So L also becomes what? L by 3. Now you know that it is applied with the same mass, so force will be same. So K into L should be equal to K dash into L dash. So KL is equal to, this is 3K into L dash is L by 3. So 3 will be constant. So you can say for any spring, K into L is a constant. K into L is a constant. Now, when K into L is a constant, K is inversely proportional to the length, isn't it? When K becomes 3 times of K, easily you can tell L dash will become L by 3. L dash will become what? L by 3. So totally we have 3 springs. Each spring is having a constant of 3K. This is 3K. This is 3K. So each spring is having 3K, 3K, 3K because L and K are inversely proportional. If all the 3 springs are in parallel, what is the effective constant? Effective constant is 3K plus 3K plus 3K, that is 9K. So K value will be 9K. So T2 will be equal to 1 by 3 times of 2 pi into root of m by k. This 2 pi into root of m by k is the initial time period, that is T1. So T2 value will be 1 by 3 times of T1. 1 by 3 times of T1. So what will be the T1 by T2 ratio then? T1 by T2 ratio will be equal to how much? 3 by 1. So what is the ratio? 3:1. Yeah. There is a tuning fork. An air column is there whose temperature is at 51 degrees Celsius. That is producing 4 beats in 1 second. 4 beats in 1 second. When sounded together with the air column, the number of beats decreases. Second one will be decreases. When the temperature becomes 16 degrees Celsius, only 1 beat per second is produced. What is the frequency of the tuning fork? Assume let F is the frequency of the tuning fork. What is F represents? F represents the frequency of tuning fork. F represents the tuning fork frequency. Now, Initially for this, we have a beat frequency of 4 initially. So F plus 4 initially. When it is increased the temperature, it has only 1 beat per second later. It may be plus or it may be minus. So F plus or minus 1 will be equal to, and you know that the frequency is directly proportional to root temperature. So first temperature is 51 degrees Celsius plus 273. So it is 324 Kelvin. And the second case 273 plus 16, that is 289 Kelvin. Root 324 is 18. Root 289 is 17. So on do cross multiplication, 17F plus 68 is equal to 18F plus or minus 18. So this clearly tells 17F ಈ ಕಡೆ ಕಳಿಸಿದ್ರೆ minus ಆಗುತ್ತೆ. 18F minus 17F equals to F, which is equal to 68 plus or minus 18. So F value will be equal to 68 plus 72, that is 18, that is 86 hertz, or you can say 68 minus 18, that is 50 hertz. Among these two, only one option is there, that is 50 hertz. So option D is the frequency of the tuning fork. Look at the next circuit. In the given circuit, initially K1 is closed. Initially K1 is closed and K2 is open. So this K2 is open, K1 is closed. So Q1 and Q2 dash are the charges on C1 and C2. V1 and V2 are the voltages respectively. Then what happens? So whenever if you close one K2, if you open and if you close, reverse it. If K2 is closed, now K1 is open, then there will be a redistribution of charge. There will be a redistribution of what? Charge. So charge will get redistributed. ಎಲ್ಲಿವರೆಗೂ redistribute ಆಗುತ್ತೆ? Till the potential difference remains same. So please remember, the charge on C1 will get redistributed, but till the potential will remain same. So option 1 will be the right option. So whenever the keys are switched and closed, there will be a redistribution of charges. There will be a redistribution of charges till it attains a equal potentials. So V1 is equal to V2 and the charge distribution are equal. So charge on C1 get redistributed till the potential will remain same. So V1 is equal to V2. Look at the next problem. There is a circular loop of radius R that carries a current I. Another smaller circular loop of radius small r carrying a current I is inside the bigger loop such that they are coplanar. Coplanar means they are parallel to each other. Now the current in the loops are in the same direction. What is the magnitude of the torque? So please remember, torque will be 0 because whenever they act parallel, there will be no rotational effect. There will be no rotational effect if the two forces are parallel. For example, if I consider this is a rod, you can get the experience of the rotational effect. If the two forces are in the opposite direction, this will be the rotational effect. But if the two forces are acting in the same direction, the body will not having any rotational effect. So the net torque value will be 0. So if the currents are since the currents are coplanar, they are parallel to each other. If they are parallel to each other, then the torque is going to be 0. The torque is going to be 0. Yeah. Look at this problem. I think it's a very quite important and it is a very concept based question. You have to be very, very, very careful while solving this. Now you have to find the position of the image formed by the lens combination given in the figure. Now look at the diagram here. The object is at O. This lens is having a focal length F, that is 10 centimeter. This is at a distance of 30 centimeter. And here I'm going to place one concave lens they are placing. The focal length of this concave lens is minus 10 centimeter. Then there is one more convex lens is placed here. That convex lens focal length is 30 centimeter. The distance between the first two lenses is 5 centimeter. The distance between the next concave lens and convex lens is 10 centimeter. Now for this, you have to find the final image position. Where is the final image is going to be formed? You have to be very smart enough, students, here. When the object is placed for the first lens, you have to find where will be the image. So first case, for the first lens, what is the object distance? Minus 30 centimeter. For the first lens, for the lens 1 I'm talking, the object is at 30 centimeter. So whenever the ray is incident like this, the image will be formed. Where the image will be formed, you have to find. For this, the focal length is 10 centimeter. You know how to find the image distance by using for the convex lens. According to your lens formula, V is equal to UF divided by U plus F. U is minus 30 into 10 divided by minus 30 plus 10, which is equal to 15 centimeter. So what is the image distance? 15 centimeter. So 15 centimeter means it will be formed here. So this is the position of the first image, I1. Now, this image will act as the object for the second lens. It will act as the object for the second lens. And you can notice for the third lens, what is the focal length? The focal length value will be 10 centimeters or for second lens. For second lens, the focal length is 10 centimeter. So from year to year, it is 10 centimeter means for second lens, the object U will be at focus. It will be at focus, that is 10 centimeter. When the object is at 10 centimeter, the image is formed at 15 centimeters. So that image will act as the object for the second one. For the second concave lens, what is the object distance? Object distance is 10 centimeter. So focal length and object distance are equal. So this clearly tells the object is formed at the principal focus. If it is formed at the principal focus, how the ray will pass? The ray will pass parallel. The ray will pass parallel. So from the concave lens, the ray should get parallel. The race should go parallel. For parallel race, if you incident, then the race will converge. The race has to converge to one particular point. This is the principal focus of the convex lens. It is 30 centimeter. So the final image is going to be formed at what distance? The final image is going to be formed at 30 centimeter. 30 centimeter. So it is at a distance of 30 centimeter. It is at a distance of 30 centimeter from the convex lens of focal length 30 centimeter. So first option is the right answer. First option is the right answer. So I think it is a twist problem, but if you analyze it, I think you can simplify. Look at the next problem. What is the maximum angle of incidence I for the total internal reflections to takes place? According to the concept of your optical fiber, to undergo the reflections internally, sin I should be equal to root of mu1 squared minus mu2 squared divided by the air medium refractive index, that is mu air. So sin I is equal to, what is the first angle of refractive index they have mentioned here? That is 3/2 squared. The surrounding medium, if they have not mentioned, means 1 air medium refractive index 1 divided by 1. So sin I value will be equal to root of 9/4 minus 1, which is equal to 5/4, which is equal to sorry, mu value is given as root 3/2, no? So root 3/2, so square and square root will get cancelled. It will be 3 only. It is root 3/2. So it will be 3/2 antandre, it is root of 1/2, that is 1 by root 2. So if sin I value is 1 by root 2, can you tell me what is the value of I? I value is 45 degree. So angle of incidence is 45 degree. So I should be 45 degree. Look at the next one. Two points, white dots or 1 mm. They are expecting to find the maximum distance where that can be resolved. So you know that the limit of resolution d theta is given by 1.22 times of lambda divided by a, 1.22 lambda divided by a. Hello, hello. Class ಇದೆ. ಇದು ಮಾಡ್ತಾ ಇದ್ದೀನಿ. 7 ಲೇಟ್ ಆಗಲ್ಲ ನಿಮಗೆ. ಲೇಟ್ ಆಗಲ್ಲ ನೋಡು ಇನ್ನು 6:20 ನೋಡಪ್ಪ ನೋಡ್ಬಿಟ್ಟು ಫೋನ್ ಮಾಡಿ. So you know that d theta can be taken as, suppose if these are the two dots which is separated by 1 mm, this distance I'm keeping as d. Now this is going to be resolved at this angle. This is d theta. This is d theta. Now there is one convex lens here. The aperture I'm going to denote with A. The aperture is denoted with A. So d theta equals to 1.22 lambda divided by A. D theta arc length can be taken as 1 millimeter divided by this distance D. So 1.22 lambda divided by A. Now they're asking you to find small d. So it is 1.22 lambda divided by A. This I'll take it as 10 power minus 3 by d. On cross multiplication, d will be 10 power minus 3a divided by 1.22 lambda. So d equals to 10 power minus 3 into, what is the value of a? A value is how much they have given. Diameter, pupil diameter is 3 mm. 3 into 10 power minus 3. 1.22 lambda is 500 nanometer. 500 nano means 10 power minus 9. So this value will be 3 into 10 power minus 6 whole thing divided by how much? 1.22 into 500. Approximately you can take 1.22 into 5 will be 6. To this 2 zeros I'll take it here. So 6 into 10 power minus 7. 3 by 6 is 1 by 2. 1 by 2 is 0.5 into 10 power 1. That value will be equal to 5. So option 3 is the right answer. 5 meter is the distance from the two dots to the lens. Look at this problem. When 92 uranium-235 undergoes fission, about 0.1% of the original mass is converted into energy. 92 uranium-235 should undergo fission per day in the nuclear reactor to produce 200 megawatt. You know that the mass 0.1%, that is m into, in grams to convert into this thing 10 power minus 3, and c squared value is 3 into 10 power 8 whole square, that is 9 into 10 power 16. That value will be equal to power into time, that is 200. Mega means 10 power 6. 10 power 6, that is undergoing for 1 day. 1 day means 24 hours. 24 hours is 86,400 seconds. So power into time is nothing but the energy. Energy is nothing but m into c square. If you simplify for m, how much you are going to get? 2 into 864 into 10 power 2 zeros, 2 zeros, 10 power 10 divided by 9 into 10 power 13. This approximately you can tell 2 into 8.64 into 10 power 12 divided by 9 into 10 power 13. So this is approximately 17 divided by 9 into 10. So this is approximately, you can say it is minus 1. 17 by 9 is approximately, you can say 2. Close to 2 into 10 power minus 1. Or you can take this as 20 into 10 power minus 2. 20 into 10 power minus 2 kg. 20 into 10 power minus 2 kg. So approximately you can take 19.2 into 10 power minus 2 kg. Look at the next problem, students. Photons of energy. How much energy? 2 electron volt. That falls on the metal plate. That releases photoelectrons with maximum velocity v. By decreasing the wavelength to 25%, what is the maximum velocity of the photoelectrons? That photoelectrons is doubled. What is the work function of the metal? First, let me get the formula for velocity. You know that kinetic energy of mv squared is equal to total energy minus the work function. So velocity value will be equal to root of 2 times of energy minus work function divided by the mass. Divided by the mass. Now, coming to the second equation. For that, the wavelength is decreased by 25%. So wavelength is decreased by 35% means the final length will become 75%. 75% means 3/4 of that. When lambda is 3/4 of lambda, energy must be equal to 4/3 of E. You know that energy is hc by lambda. So how the energy and wavelength are related? It is inversely proportional. If wavelength becomes 3/4 of lambda, energy will become 4/3 times of E. 4/3 times of E. So can you write the second equation? Second equation, V dash value will be root of 2 times of E becomes 4/3 E minus work function divided by the mass. You can call this equation as 2. Now you can divide equation 2 and equation 1. If you do that, it will be V dash by V is equal to root of. This 2m will get cancelled out. So it will be 4/3 E minus 5 divided by E minus 5. Now they are telling that after decreasing the wavelength, the velocity becomes doubled. After decreasing the wavelength, the velocity becomes double. So V dash value will be equal to 2 times of V. So V dash value will be 2V by V, which is equal to root of 4/3 E minus 5 whole thing divided by E minus 5. So you can tell V and V is going to get cancelled out. Squaring on both the sides, so it will become 4. It will be 4/3 E minus 5 divided by E minus 5. On cross multiplication, you can tell 4E minus 5 is equal to 4/3 E minus 5. So on cross multiplication, 4E minus 4/3 E is equal to 4/5 minus 5. So 4 3s are 12, E minus 4, that is 80/3 is equal to 3/5. So what is work function? It will be 8 times of E divided by 3 3s will become 9. So what is the work function actually? It is 8/9 times of E. But what is the energy they have given? Energy they have given, no. How much is energy is given? 2 electron volt energy is given. So 2 by 9 into 2, that value will be equal to 16 by 9. 16 by 9 is approximately 2, close to 2, or you can tell directly it is 1.8. 1.8 electron volt. So option 4 is the right answer. So what is the work function, students? Work function is equal to 1.8 electron volt. Yeah, look at this problem. Actually, this problem is based on the transistor. Now they're asking you to find what is the value of the base resistor. Remember the formula, base current IB is equal to VCC by RB. So what is RB then? Voltage across the collector divided by IB. So how to calculate IB then? IB is calculated by using IC by beta. Sir, what is beta? Beta is given 100. Beta is given 100. So what is IB? IB is IC. What is IC? You have to calculate by 100. So IB value is IC by 100. IC by 100. So RB is equal to VCC by IB is IC by 100. 100 goes up. 100 times of VCC by IC. Now, which is equal to by Ohm's law, I is equal to V by R. R equals to V by I. VCC by IC. Now, what is VCC? They have given it as 10. But what is IC? IC is VCC by R. VCC by R. So VCC is 10 by R is 1 kilo. When 1 kilo goes up, it will become cancel out. So 100 kilo ohm. 100 kilo ohm. But in the case of the base resistor, this is common for both ear as well as for ear. So when both the cases are there, so total effective resistance in B value will be 2 times of 100 kilo ohm. So it will be 200 kilo ohm. So it is common. Emitter is common for both input as well as for output. So resistance will become double of this 100 kilo ohm. That is 200 kilo ohm. That is option 1 is the right answer. Look at this. Young's double slit apparatus is shown in the figure. This is the figure. This is monochromatic source. This are the two slits. This is the pitch. Now you have to write the conceptual this thing, match the following. Now, which is the right option? Option has to be defined here. Option is not defined here. Yeah, actually here the options has to be defined. This is not defined. Option has to be defined. It is not defined. Okay. Yeah. Look at this. They are given one particle motion which is along a straight line, that is velocity versus time. Then you have to give the entries in the column 1 and column 2. First column, time in seconds at which the particle is at rest. When the particle is at rest, definitely it has to be 0. Velocity has to be 0. So one should matches with r. But here the number is mentioned. So when the particle is at rest, the point should be at 3. Here the particle will be at rest. So one should matches with q. Second one, even r is also fine. It is also 0. So q comma r. So q comma r is there in the third option and in the second option. Look at the second point. At what point the particle reverses its direction after completing one cycle at the point 3. So 2 goes to q. 3. What is the average acceleration between the instant of time 1 to 4 seconds? 1 to 4 seconds, what is the instantaneous acceleration? It has to go 2 cycles. So 3 has to reach us to the point P. The instantaneous acceleration at the third second value will be, the value will be 4. At the point 4, the velocity is 4. So acceleration reaches with 4. So it is yes. So option 3 will be the right answer. Option 3 will be the right answer. F is equal to sine omega t plus cos omega t. Sine 6 omega t will be the periodic function with a time period 2 omega by. All sine functions are periodic. So this assertion is going to be true. Because each term is a function of periodic function. Yes. So even the reason is correct, and reason is the correct explanation for assertion. So option 4 will be the right answer. So this is the paper 5 synopsis, students. Now you can take about what the first chapter synopsis, that is motion in a straight line. In the motion in a straight line, the first concept you have to introduce the average velocity. What is average velocity? How to determine average velocity upon? Now, average velocity is a formula. One is 2 v1 v2 by v1 plus v2. The another average velocity value will be v1 plus v2 by 2. ಇದನ್ನ ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ this is for equal time. ಇದನ್ನ ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ equal distance ಅಲ್ಲಿ ಇದ್ರೆ. Please remember, when the particles are covering equal distances, the average velocity value will be 2 times of v1 v2 by v1 plus v2. When it is at the equal intervals of time, then average velocity value will be equal to v1 plus v2 divided by 2. This is for the average. And you know the instantaneous velocity is given by dx by dt. Instantaneous acceleration is given by dv by dt. Then you have to remember the stopping distance concept. Stopping distance. Remember, whenever the stopping distance is there, u squared should be equal to 2as, where 2a is a constant, so u squared is directly proportional to s. So whenever the moving vehicle applies the brake, if it is moving with a less speed, the stopping distance will be very less, because s is directly proportional to u squared. Since S is directly proportional to u squared, if you apply the brake, the stopping distance will be less. Suppose if the speed is increased. If the speed is increased, then the stopping distance is going to be also increased because S is directly proportional to u square. So more speed, more will be the stopping distance. Less speed, less will be the stopping distance. Please be careful. This type of question is going to be asked in the exam. Stopping distance. Now, one more formula you have to remember here. Whenever the particle is dropped from rest, initial speed will be 0. So it reaches to the ground with a time which is equal to root of 2h by g if h is the height. With what velocity it reaches the ground? Velocity is given by the formula root of 2gh. So please remember, what is the velocity of the particle when it reaches to the ground? Whenever the particle is just dropped, then velocity of the particle when it reaches to the ground is root of 2gh. Whenever the particle is dropped from rest, what is the time taken? The time taken value will be equal to root of 2h by g. Root of 2h by g. So the time taken will be root of 2h by g. Velocity will be equal to root of 2gh. Remember these two formulas. Addition to this, you have to remember one more formula, students. Usually they will ask, what is the distance traveled in the nth second? The distance traveled in the nth second. The distance traveled in the nth second is given by the formula u plus a by 2 into 2n minus 1. So please remember, the distance traveled in the nth second is given by the formula u plus a by 2 into 2n minus 1. I hope in the case of the graphs, suppose if you are plotting the velocity versus the time, if you want to find what is the slope of VT graph, the slope of VT graph represents the acceleration. The slope of the velocity time graph represents the acceleration. Then if you calculate what is the area of the velocity time graph, the area of the velocity time graph represents the distance covered. So please remember, what is the slope of the velocity time graph? It is acceleration. What is the area of the velocity time graph represents? Area represents the distance. Addition to this, you have to remember the three standard equation, that is V is equal to U plus AT and V squared is equal to U squared plus 2AS and S is equal to ut plus of at squared. So these are the three formulas you have to remember in the case of the motion in a straight line. Usually the problem may occur with average velocities, or the problems may come from the stopping distance, or the problem may be asked in terms of the distance traveled in the nth second. And the problem may be asked in terms of the velocity time graphs. Now, one more interesting problem will be there in this chapter, that is usually asked. There will be a tower of particular height h. Suppose if you drop the particle from down, initial speed will be 0. If you move up with some velocity u, after certain time, these two particles are going to meet. After what time it is going to meet? After what distance it is going to be meet? They are going to ask that. So this is problem is going to be asked. So if the particle is just dropped, remember the initial speed value will be 0. If the particle is thrown vertically upward, then there will be initial velocity u. So whenever the particle is thrown vertically upward, you have to take the initial velocity u. Whenever the particle is thrown upward, downward, the initial speed will be 0. So this problem will be asked. So these are the problems you have to remember, students. I mean, these are the formulas you have to remember in the motion in a straight line concept. So which are the other formulas you have remembered here in motion in a straight line? And one more, remember, students, whenever the particle is moving in the circular track, after completing one revolution, after completing one revolution, please remember the distance covered will be 2 pi r circumference, and the second one will be the displacement. Displacement value will be 0. So what is the displacement when the particle covers or completes one revolution? It is 0. What is the distance covered? The distance covered is 2 pi r. So these are the formulas, students, in the very first chapter. You remember this. In the next class, we can cope up with straight line, laws of motion, and rotational motion. So in the Thursday's class, I'm going to talk about the laws of motion, motion in a plane, and the rotational motion, because we have completed the 5th model paper. No, so we can start up the synopsis of 3 chapters in the next session, students. So thank you. I will stop at this stage. We'll continue on the Thursday's class.